Alrighty, so what we're going to do here is a GlowScript coding problem. Um, this is for Physics 2211, and this was on one of the past exams that we have taken this semester. Um, so in this question, it's asking us to write necessary statements using GlowScript and Python, which is a coding base that we have been using throughout this course. So um, I will read out the question and then I will try to work through this problem to the best of my ability. So the question states, a large metal ball of mass of m equals 50 kg is hanging motionless from a crane at location Ri equals 300 meters. Suddenly the crane malfunctions and the ball begins to fall from rest. At that same instant, the safety brake is engaged, so that as the ball falls to the ground, it experiences two forces. One, a gravitational force denoted by Fg due to the Earth, and two, a drag force denoted by Fd due to the crane's brake. The drag force is equal to 20 times the speed of the ball and points in the opposite direction of the velocity. Now complete the GlowScript code given below by adding the statements necessary to create a model that predicts the ball's motion. So in the question, what was given to us was they gave us the ball is equal to sphere, which had a radius equal to 0.3, and the color was set to blue. So this is the first line that was given. Then they gave us G, which is the gravitational constant, close to Earth. This is important because close to Earth, it is equal to 9.8. Now they gave us the J hat vector. J hat was equal to the vector of 0, 1, 0. And the time, given the starting time, we start at time 0. Now our time step in this situation, denoted by delta t, was set to 0.01. So this is a very small time step. Now, the first question, I will start here. The first question is saying, add the three necessary statements here to specify the ball's mass and initial conditions. So what we were required to do was just basically specify the ball's mass and the initial conditions which were given to us throughout the question. So, in the beginning of the question, it says a large metal ball of mass m equals 50 kg. So, in my mind, first step, well, if we're trying to find the ball's mass, we know the ball's mass is equal to 50. Now, I'm going to comment this out. So this isn't in your code, but I'm just going to do it here for reference. So this is our mass in kg, just so we know what our units are. Now, initial conditions, so I figured we want to find the ball's initial velocity. Now, this is where I made the mistake. So, initially, I had the ball's velocity set equal to 0, but initial velocity should be a vector and not a scalar. So this is where my mistake happened. So that, given that it's not moving in any direction, this could be a vector that represents our initial velocity. Now, the ball dot p in this situation, I have that set to the mass of the ball. Now this is a time sign in Python. It's the asterisk, and you times that by the ball velocity. So as the velocity is changing, that multiplied by the mass of the ball will give you its momentum. Now remember, P stands for momentum. I always confuse as position just because it's the letter P, but just remember that this stands for momentum. So to find momentum, we have to multiply the mass of the ball by the ball's velocity. And now the ball's position vector, because it gave us the ball was hanging motionless from a crane, and it gave us the location of our initial. So to find in Python, to find the location, you do ball.pos, which stands for position basically. So this is equal to, and you write vector and what they gave us. Oh, let me just do this up here. So when you're writing code, you don't have to do the triangular brackets given the format. You just do the arcs, the regular parentheses. So given the equation, this is 0, 300, 0. So given our y component, this is where it starts, 300 up y, and then our question saying it's beginning to fall, which makes sense. So now this was a two-part question. And so in the second part of the question, they gave us, I'm going to slide up just a little bit. So in the second part of the question, they gave us this. So they gave while t is less than 100. So as the time is less than 100 is what we're going to iterating through. So now our code is going to go through this line, okay? And then afterwards they gave us t is equal to t plus delta t. So just our change in time steps. And then they added a quick print statement at the end to denote the end of our code. So after our code, this is what will be printed out. We'll print out the words all done. So the question is adding the necessary statements here to determine the net force acting on the ball and update the velocity and position for the ball. So then the two forces that were listed in the beginning of the question, they said there were two forces. They had the gravitational force Fg due to the Earth and also the drag force Fd due to the crane's brake. So these are our two forces that we are solving for. So I will put the second part of this question right here. So first I want to find F-grav, which the formula for gravity, I will do the mass of the ball times the gravitational constant times the vector 0, -1, and then 0. So this right here will give us our gravity, and this right here is given the fact that we are traveling in the negative y direction, because the ball, if I drew a little graph here, if our ball starts at 0, 300, say this is 300, right? 300, 0. And if we're going in the negative y direction, that means that the ball is falling. So this indicates why this is -1. Now, F drag is a little more complicated. So for I have got a little point off on this portion. So since the drag force now depends on velocity and not momentum, so I would have to now divide the ball's momentum by the ball's mass for my code to be valid. So initially this is what I had in my code. I had 20 because it said drag is 20 times. Let's see, in the question it said the ball drag is the drag force is 20 times the speed of the ball and points in the opposite direction of velocity. So in my mind, speed is related to velocity, which I confused that with position because it said opposite direction of position or of velocity. So initially I was like, okay, I'll use position. But that's not the case. So in this case, initially I had 20 times the ball's momentum, but this is not correct. Okay, in order for this to be correct, I would have to divide this right here, ball's position, or momentum, by the mass of the ball. So, and it's also important so that this here will point in the opposite direction of velocity, not in the same direction. Now, the F net is fairly simple. Now, what is the net force is simply the forces added together. So you have F grav simply added to F drag. And now to update the ball's momentum, so now we want to update momentum. So in order to update momentum, we have to take the initial momentum, and then we have to add that to the net force multiplied by the time step. Now the ball's velocity is equal to ball dot momentum, or ball dot p, divided by the mass of the ball. So this is what would have been useful when solving for my F drag. As you see, this right here is equal to this right here. So that is the direct correlation that I missed. Now, to update the ball's position, we set this equal to, now you want to take the initial position, and the only way a ball changes position is by calculating how fast or how far the ball has moved in a given time. So given that, we want to take the ball's velocity, because this denotes how fast and what direction the ball is moving, and we want to multiply by that by, this is where we want to multiply by the time step again, because this tells us how long the ball is moving at this speed. So based on that, we can tell where it stops. And so where it stops, we can now add that to the original one to then update our new ball's position. So this was the coding for this exam. So just a little, portions in both first and second part where you can get mixed up, which is totally okay. I was fairly confused on this question myself, just given that you just really have to know your formulas. That's basically it. But I hope this explanation helped. Hopefully I was able to do a good enough job. I was able to explain to the best of my ability of what I learned and what I now know. But hopefully we can learn from this and not make the same mistakes twice. And hopefully this helped, and I wish you all the best of luck on future exams.